It's Sam the guy. In this video, we are going to talk about benzodiazepines. Here is the layout of what you are going to talk about. Please don't forget to subscribe, like the video, and share. We are going to do a brief introduction of the benzodiazepines. We talk about the general structure and SAR. Talk about the general pharmacokinetics, why some are short acting, intermediate acting, and long acting, and how can you tell that this one is short acting, intermediate, or long acting by just mere looking at the structure. We talk about the specific agents, metabolism of some benzodiazepines. We see the metabolism pathway, then clinical uses, adverse drug reactions. Then we talk about other drugs which affect the GABA receptors, gated chloride channels. Let's go. Benzodiazepines, they are sedatives, hypnotics, and anxiolytic drugs. They bind at the GABA receptor. GABA receptor. GABA is the major and most common inhibitory neurotransmitter. Inhibitory neurotransmitter in the brain. In the brain. This GABA has two types. We have the ionotropic and metabotropic. But for the benzodiazepines, they bind at the ionotropic GABA receptor. And this one is a pentamer. Pentameric. It is made up of 2 alpha, 2 beta, and 2 and 1 gamma subunit. That's why it is a pentamer. There are 5. And this one, when the benzodiazepines bind, they lead to increase in affinity for GABA, or they increase GABA binding. This leads to the opening of the chloride channel opening. And we shall have influx of the chloride. Influx of the chloride. This leads to hyperpolarization. Hence, there is inhibition of the neurotransmitter, or of the neurons. So, these benzodiazepines, they are allosteric inhibitors. And you can call them GABA potentiators. They are not GABA mimetic, but they are GABA potentiators. When they bind, they lead to the conformation changes. Then the GABA binds to its receptor, leading to the opening of the chloride channels. Hence, we shall have inhibition of the neurons. What I'd forgotten, this ionotropic has the GABA A and GABA C. For benzodiazepines, they bind at GABA A, which is the pentameric and all other things. Then metabotropic, this one have the GABA B. When it comes to these pentameric subunits, alpha, it has isoforms. Where you have alpha 1 up to alpha 6. For beta, we have beta 1 up to beta 2. Gamma, we have 1 up to gamma 3. Alpha 1 and alpha 2 are the main sites for binding of the benzodiazepines. This alpha 1 is responsible for this ash. That is amnesia, sedation, and hypnosis. Then for alpha 2 is responsible for we have the anxiety and muscle relaxation. So if a drug has high affinity for alpha 1, they are marketed as sedatives and hypnotics, and they have a side effect that they can cause amnesia. For those which have high affinity for alpha 2, they are marketed as muscle relaxant and anxiolytics. For diazepam, this drug has similar affinity for all isomers, the alpha 1 and alpha 2. That's why for it can be used as sedative, hypnotic, anxiolytic, and muscle relaxant. Wait, it has a broad binding or broad affinity for all subunits. Yes, same kind of guy. For the general structure, this is the general structure of benzodiazepine. This is the general structure. This is position 1, this is 2, this is position 3, 4, 5, 6, 7, 8, and 9. This one will be 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, and 6 prime. This structure is called 5-allyl. At position 5, you have the allyl group. Then position 1 and 4, we have nitrogen atom. So it is 5-allyl, 1,4 benzodiazepine or diazepine 2-on. This is benzodiazepine. At position 2, you have a keto group. So it is 5-allyl, 1,4 benzodiazepine 2-on. For the general SAR, let's begin with this ring. This ring, the benzene ring, or it can be heterocyclic for some benzodiazepine. This ring is responsible for pi stacking at the GABA receptor. This pi stacking, it interacts with the aromatic amino acids. That's the role of this ring. And at position 7, 7th position, these benzodiazepines, addition of an electron withdrawing group increases the activity. So the more the electronegative, the more electronegative the substrate is, the more activity of the drug. Electron withdrawing or electron negative. The more electronegative, the more activity of that drug. For example, if you have this group, the nitrous group at this position, it increases the activity than the chloride group. They are both electronegative, but this one is more electronegative than this group. So meaning that this drug will have higher activity than this one with the chloride atom. When it comes to position 1, That nitrogen group is essential. Must be there. And also, this other group, addition of alkyl group, increases tolerance or leads to tolerance of that drug. Mean that the drug is tolerable compared to those without this R group. When it comes to position 2, we have position 2. That keto group or that oxygen atom is very essential. Or the carbonyl group is essential. And addition of a proton accepting group here, of course, this oxygen is a proton acceptor, and other proton accepting group, increases activity. It increases the activity of the drug. So, addition of an azo. This can be imidazole or triazo. At this position 2 and 3, if they are fused to form imidazole or triazo at this position, we are going to see the drugs. This one increases the penetration of that drug, so that drug will be short acting. That drug will be short acting and to be highly metabolized. And there is high redistribution. It increases redistribution of that drug. When it comes to position 3, this position 3, addition of alkyl group decreases the activity. While addition of hydroxyl group at this position does not affect the activity but increases the hydrophilicity of the drug, water solubility. Increase in water solubility means that this drug, much of it will be in blood, so much of it will be excreted in urine. And can undergo glucochylonidation, then it be excreted in the urine. Also meaning that if it is excreted in urine, it will reduce the half-life of the drug. So these drugs having the OH group at this position, they have also shorter half-life. When it comes to position 4, this position 4-5 bond, 4-5 double bond. This double bond should not be saturated. Or shifted. If it is shifted maybe to 4-3 position, this decreases the activity. Now, when it comes to this phenyl group at position 2', addition of electron withdrawing group or electronegative atom increases the activity. And if this group is added at position 2 and position 6, it's the same. Position 2' and 6', addition of electron withdrawing group or electronegative group increases the activity here at this position and this position. Then when it comes to position 3, prime. This one decreases the activity. If electron negative or electron withdrawing group is added at this position, it decreases the activity. And also at position 4 prime, the activity decreases greatly at this position, or the para position. This is the para position, and this is the meta. But for the ortho position, that is 2 prime and 6 prime, the activity increases. But at this position 4 prime, or the para position, the activity decreases greatly. Now we have position 6, 8, and 9. Position 6, 8, and 9. This position should not be substituted with any group. Should not be substituted. Substitution of those positions decreases the activity. If those groups are substituted, we shall have decreased the activity.